Monday, right? Okay, class full IP address scheme. Okay, basically, IP address have typically you need to remember A, B, C, class A, class B, and class C. Class D, yes, you need to know just a few category for class D. Okay, so as we can see here, uh, network classes for class A, for class full, class full, we have 8 prefix, which is for this the decimal. Okay, start from 10.0.0 through 126.255.255.255. Okay, so for the binary map should be this way. Okay, 0 n dot h. Okay, n mean network, stand for network. H mean stand for host. For class B, is a 16 prefix. Start from 128.0.0 through 191.255.255.255 in decimal notation ranges. And for the bit binary or bit maps, it start from 10 n uh, 10 n dot n h so on for this one. Okay, as you know, like 0 1 0 1 1 0 1 1 1 0 and 1 1 1 is a fix, you cannot change. Okay, the only variable that can change is uh, either n or h. N for stand for network, h for host. Okay, if you can see here, there's no 1 to 7. Okay, 1 to 6 jump to 1 to 8. Okay, 1 to 7 reserved for local loop, local host, or sometimes called loop back. Okay, loop back normally you can configure or set, or sometimes defined by your PC, your computer, your server. Normally, okay, if you want to do testing, right, you can configure or setting like 127.0.0.0.1 or something like that. Sometimes your loopback is 169 dot something something. Let's say you want to connect Wi-Fi and but you cannot get the IP addresses. So what happened? Your PC will appear 169 something. Okay, that is also loopback. Okay, right. For class C, sometimes we call /24 prefix. Uh, Start from 192.0.0.0 through 223.255.255.255. So this is in decimal range. And for the binary map, binary number, it start from 110 and so on. Okay, so what does mean of 24 prefix mean? 1 block, 2 block, 3 blocks. So 8 plus 8 plus 8, you got 24. For 16 mean this one, 1 2 3. Oh, sorry, 1 2. Okay, and then for 8 prefix, that means just one. Oh, sorry, you look into, sorry, again, for 8 prefix mean this one, the n. That mean 1 block of 8 bits. 16 prefix mean 1 block, 2 block. And for /24 mean you have 3 blocks of 8 bit for the network. Okay, 1 2 3. Okay, so that's that mean of prefix in this context. Okay, in this context. Okay, for class D, sometimes we call multicast. Okay, it start from 224.0.0 through 229.255.255.255. So, okay, basically class D is generated by system or predefined by system. For example, okay, for the multicast mean something like live, like TikTok live, so Google Meet, Zoom. So the system will provide generate the class D. Okay, class D IP addresses. Or sometimes for the routing, like for example, for OSPF routing. So system as defined like 224.0.0.1, 224.0.0.0.2, This is predefined by system. So basically, we only create, okay, for the engineer, or we can plan for IP address for class A, B, and C. Class E, you don't have to remember because class E is experiment. But it start from 240.0.0 through 247.255.255. Class E is basically is, is not used at all. Okay, right. Class full normally used for the IP version 4 global addresses used by internet. Okay, right. However, they have special addresses. Okay, uh, mean special block. For example, all zero addresses or default route. That means 0.0.0 in decimal, 0.0.0.0, or in network address. For example, in decimal, 255.255.255.255. For all ones addresses, okay. Sorry, for all ones address, sometimes we call limited block address. So what does it mean? If if you have 8-bit in binary, when you say 1.1.1.1.1, when you convert it, it becomes 255. So this is, we call it broadcast address. Loopback address or local addresses, X. All right. Private addresses, I will explain after this slide. And multi addresses. Multi addresses is class T. Special address in each block, network address and direct broadcast address. So network address, depending on the calculation, you have 0.0.0.0.0 and after for the all. Okay, so when convert to decimal, it become 0.0.0.0. However, for the broadcast address, normally is 255. So where it come from? In binary, 1.1.1.1.1.1, and you convert become in 255 in decimal. Hmm. Right, private IP addresses. Okay, this private addresses is very, very important because it designed for the local area network. Okay, these IP addresses are for version 4. We not cover version 6. Okay, so a set of specific ranges of IP addresses have been set aside for use in private networks. Okay, as described in RFC 1918 standard. So you can find in ChatGPT, just type RFC 1918, they will they will tell you what is the uh, addresses for the private IP, right? Right. These addresses are used within intranets, okay, that do not connect directly to internet, are considered unregistered and router in the internet must discard packet with these addresses. Okay, what does it mean is that this private IP address is not global IP address. Router or internet does not recognize this IP address. Okay, dia tak faham. They cannot see. Let's say, for example, 172.16.1.1, you configure in router, it will reject because they are not recognize this IP address. This IP address for the local area network. Okay, and then network address translation or NAT used to convert between private IP addresses and global IP addresses. So what happened? Since local area network use different IP address, right? Different segment IP address. So in order for you to communicate to the internet, you need to have one mechanism we call network address translation. It's like you translate between private IP address to global IP address. This is firewall job. Normally firewall we do anything. Okay. Okay. Private IP address space. So basically these IP addresses is not recognized by internet. Internet does not recognize this IP address because this is reserved for local area network. So for example, okay. So basically, the private IP addresses have three classes. Class A, sometimes we call 10/8 prefix. 10 mean 10.0.0 through 10.255.255.255 in decimal. Okay. Okay, the subnet normally start 255.0.0 and number of network is 126 network. Okay, and for the class A, you can setting or configure up to 16 million hosts. Maksudnya PC, tablet, whatever devices you can have. So normally for class A, we design for small, not much network, not much VLAN, but you require a lot of devices that have IP addresses. Okay, so it is the range uh, for class A. For class B, normally we design for medium. Okay, medium. So class B is sometimes go 172.16/12 prefix. Okay, so the decimal network address range in decimal start from 172.16.0.0 through 172.31.255.255. Okay, and then the subnet mask. Okay, the subnet mask is 255.255.0.0, and for the class B, for private IP address for local network, you can configure up to 16,383 network address, or sometimes we call VLAN lah. Okay, you can have up to 16,000 VLAN. And your host for each VLAN can up to 65,534 devices, NPC, mobile phone, any device, server, and so on. All right. For class C, sometimes we call 192.168 per slash 60 prefix. Okay, the network address range in decimal start from 192.168.0.0 through 192.168.255.255. So normally they have one network address range. Okay, and then subnet mask is 255.255.255.0, and you can have up to 2 million networks or 2 million VLANs. You can configure it, and each of VLAN, the VLAN or networks, you can configure up to 254 hosts. Okay, 254 hosts. Seven. This is reserved. Okay, and the subnet is 255.255.255.0. For broadcast address is 255.255.255, and for default route network is 0.0.0. So this IP address is not recognized by internet. Okay, BGP or whatever internet, they don't understand. Even router don't understand this. Okay, this is used for local area network or VLAN. Yeah, right. Subnet addressing. Okay, subnet addressing introduce another hierarchy level. Okay, transparent to the remote networks, simplify management if multiplicity of LANs, masking used to find subnet number. So basically, it's 10. 10 is class B, yeah, 10. See, okay, 10, and then you have network ID and host ID, and after you subnet, it become 10 network ID, and you have the host is divided to subnet ID and host ID, something like that. Okay, subnetting. What is subnetting? Okay, they have two concepts. One we call subnetting. Subnetting normally we do in local network, and supernetting. Supernetting normally we design for the internet design, IP address. So in subnetting, we need the first address of the subnet and the subnet mask to define the range of addresses. Okay. In supernetting, we need the first address of the supernet and the SuperNet mask to the one eight until RFC 1520. RFC means request for comment. So just go to ChatGPT, just type RFC 1518. Okay, what is that? You can get more information about this. Right. So CID allocation principle follow the next, which is IP addresses should be assigned on this basis. Okay. IP address assignment reflect physical topology of networks. Okay. TRD, transit routing domain, have a unique IP prefix. Okay. Carry traffic between routing domains. Interconnected non-hierarchical cross-national boundaries. Most routing domains, single home attached to the single TRD. Single home in uh, one provider. For example, let's say you work in one company. Okay, maybe the company name was ABC's number hard. Okay, you are network engineer. Okay, so your manager asks you, okay, I want to subscribe network internet. So you subscribe from, for example, telecom TM. Okay, a metro internet, for example. So if you subscribe one what we call provider, let's say TM, we call single home. However, let's say your network is very critical to user. For example, using to access 24 by 7 cannot fail. So you need backup line. Okay, backup the line. So for example, you apply for Maxis, for example. So you have primary internet link using TM and secondary uh, internet link using Maxis. So these two provider we call dual homing. So maksudnya dua provider lah. Right. Okay, implementation primary through BGP version 4. Okay, so CIDR normally we use when we want to configure border gateway protocol. Border BGP version 4 only for internet. Okay, this is X3. Dia bukan OSPF, RIP and so on. That one is for local network. So you can have more detail for BGP version 4, just type RFC 1520 in ChatGPT. Okay, right. Longest prefix match. Okay, so the longest prefix match actually is several fast longest prefix matching algorithm are available. Multiple entry may match a given IP destination address. HCDR impact routing and forwarding. Okay, routing table and routing protocol must carry IP address and must. So for example, for longest prefix match, okay, you have routing table that contain, for example, your IP address is 205.100.0.0/22. This is class C, right? Which correspond to the given supernet. Okay, 20205.100.0.0/20. So this one /22. So the summarize becomes /20. Okay, which result from aggregation of larger number of destination into supernet. So prefix tu makin kecil, from 22 become 20, kadang /4, for example. Packet must be routed using the most specific route that is the longest prefix matching. Okay. Alamak. Okay. Okay. We continue with other topic. Yeah. Okay. Wait for 1 minute. Okay. Wait for 1 minute. Stream 2, we need to learn a bit about how to design network lah. Okay. If you don't know networks, for example, it's difficult for you to understand network security lah. Okay. Okay. Right. So basically, you need to learn about VLSM design, subnet. This one is just basic, okay, not detailed, right? Okay. Subnet design consideration. Okay. So basically, the criteria for the deploying of address plan. So basically, let's say you work in okay, you work in TM, or maybe you work in a provider company, like maybe from Amazon ke, you work in cloud ke, you work in time.com ke, Maxis ke. This one is basic for the network engineer. Network engineer tu umum. That means either you are network security, you planning, network planning, and so on. You need to know this one. Very basic. Okay. Or probably you work in maybe not a provider. Maybe you work in DHL ke, logistik ke, you Post Malaysia ke, MAS ke, AirAsia ke, MISC ke, Navy ke, hospital ke, apa-apalah. Well, any IT department, this one is very basic. You must know how to design IP address. Okay. So what the criteria that you need to know, number one is how many total subnet does the organization need today? Berapa banyak? Okay. How many total subnet will the organisation need in the future? So you bila you plan, you kena tahu what is the current requirements. Okay, what is the next 3 years, the next 5 years. So you kena ada planning. Okay, you need to have planning so that IP address tu tak membazir ataupun your IP address is not enough to cater the next future lah. So how many hosts? Tadi subnet kan, subnet mean VLAN kalau dalam local network panggilan. Kalau for the wired network, sometimes we call subnet lah. So how many hosts are in, how many hosts are on the organization largest subnet today? How many hosts will there be on the organization largest subnet in the future? So you can tahu lah current and future, how much. Okay, example. Given network address a.b.c.d/x are required n host number. Okay, find number of queue subnet. So sekarang ni you ada you require maybe n host number, n maybe 25, 100. So the step that to solve this problem, number one, you need to define the subnet mask, which is extended prefix links. Define the subnet number, the all zeros subnet and all ones, and then subnet defining host address for each subnet, defining the broadcast address for each. This is step lah. Okay. This one is ideally lah, tapi kalau you boleh ingat cepat or maybe you have shortcut, that's okay. Tapi this is the basic thing that you need to know lah. Okay. So for example, okay, an organization is assigned the network address 193.1.1.0/24. Okay, this is global IP address, and it needs to define 6 subnet. Okay, the largest subnet is required to support 24 hours. So basically jadi, kalau you ada network lah, contoh you nak kena design core network atau wide network, and there's a lot of branches. Okay, katakanlah your company tu you kerja dekat ni lah, katakan you kerja dekat AirAsia. Okay, so you ada banyak branches. Okay, maybe each of the airport mesti ada AirAsia punya branch kan, macam contohnya Alostar, lagi mana Penang, Ipoh, JP, KT, KB, so on. Macam itulah. So you need to design. Let's say you are given 193.1.1.0/24. So you need to seek subnet. Maksudnya macam you nak 6 branch. Setiap satu branch tu perlukan 25 host, 25 PC. Okay, so macam mana define? First, define the subnet mask. Okay, and extended prefix length. Okay, then define the subnet number there. The all 0 subnet and all 1 subnet. Defining host addresses for each subnet. Defining the broadcast address for each subnet. So ini dia punya tips dia lah. Okay, rule of thumb lah. Tapi tak semestinya follow macam ini lah. Tapi ini yang rule of thumb dia. Okay, so buat macam ni sama. So first, defining the subnet mask and extended prefix. So determine the number bit required. So question tu dia nak 6 subnet, maksudnya dia nak 6 branch lah. Okay, 6 branch subnet. Kalau dalam local network dia panggil VLAN lah. Tapi yang ni wide area network, so kita panggil subnet. Okay, so 2 power 3 you got 8. Okay, so yang nearest kita tak ada 2 kuasa berapa dapat 6. So the nearest is 2 power 3 you got 8. Okay, so you have 3 bits here. This one are required to enumerate the 8 subnets in the block and have 2 unused subnet reserved for future growth. So basically you nak 16 saja. Okay, tapi mana ada 2 kuasa berapa dapat 6. So takkan 2 kuasa 4, 2 kuasa 2 4. 2 power 2 is 4, 2 power 3 is 8. Okay, so 8 okay lah, maksudnya you still in the requirement. Okay, fulfill the requirement. So you ada balance 2, 8 tolak 6 dapat 2. So 2 unused subnet. Mungkin akan datang Asia dia nak buat dekat Kuching dengan Sabah pula, Kuching dengan Kota Kinabalu. So kita ada reserve 2 kat sini. Itu maksud dia. Okay, the organization is subnetting /24 and extended network prefix become /27. Ni macam mana nak dapat? So basically buat macam ni. Okay, tapi dalam as ni kalau buat satu-satu tak siap kita. So ini cuma kita nak terangkan macam mana benda tu dibuat. Okay, okay, so for example you have 193.1.1.0/24 is given. So this one dalam decimal. Okay, so you kena convert dalam binary. So 193, ambil calculator, make sure you bring calculator. 193 convert ke binary guna calculator, you akan dapat 11000001. Okay, and then kalau 1 dapat ni lah kan, 1 dapat 1, 0 lah. Okay, so you buat table macam ni. Okay, so you dapat this column we call network, this column we call network prefix. Okay, right. Lepas tu apa? Macam mana dapat 27 ni? Macam mana dapat 27 ni? So tadi kita ingat kita ada 2 kuasa 3, 2 power 3. 4 campur 3 dapat berapa? 7. Betul? 2 kuasa 3, 8 ni, 3 ni, 3 bit ni, 24 campur 3 juga 27. So apa maksud dia? 27 ni. Allah. 27 ni maksud dia macam ni. You ada 27 ni, satu-satu sampai 27. So 8 campur 8 campur 8, 24 campur 3. 3 bit sini, 3. 1, 2, 3. So 24 plus 3 you got 27. So this one, okay, this one, 1, 1, 1, 1, 1, 1, 1, 1, you convert dapat apa? 255, 25, 25. So sini ada 3 bit kan? 1, 1, 1, 0, 0, 0, 0, 0 in binary. If you convert in decimal, you got 2 to 4. Okay, you got 2 to 4. So this one, this arrow yang warna hijau ni, the green color, we call extended network prefix. Okay. However, for this particular dotted line ni, we call subnet. Okay, subnet, and this one number, host number lah. Okay, this one. Alright, so next, defining the subnet number. So sekarang ni kita ada 8. 2 power 3 you got 8. So basically 8 actually, when you convert it become 1, 2, 3, 4, 5, 6, 7, 8 kan? Betul. But you in binary, you got 0.0. Lepas tu 1 become 0.1, 2, 0.10, 3, 0.11 and so on. So apa maksud saya? Yang ni adalah di sini. Okay, the dotted line. 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7. Sama lah. 1, 2, 3, 4, 6, 7. Okay. And then base network kita is 193.1.1.0/24. Ini yang given. Okay. So this is 193, 1.1.0, and you convert dalam decimal, you akan dapat samalah 193.1.1.0/27. This one akan jadi apa? Dia akan jadi 32 lah. 0.0.1.0000 is 32 /27. Okay, sebab kita dah masukkan subnet. Okay, so on. Yang 2 ni akan jadi 64, 3 akan jadi 56. This one 4 become 128, 5 160, 6 become 192. So sekarang ni kita nak test sebab kita perlukan 6 subnet. Right, 6 subnet, right? So maksudnya kita cubalah ambil okay, 6 subnet, 110, this one. So 193.1.1.192.627. Okay, and then second step, to all zeros. To all zero mean dekat sini. Okay, 193.1.1.0/27. All zero mean this one is network route. Oh, sorry, this is default lah. Okay, and kalau all one, maksudnya kat sini, ujung 111. Jadi 193.1.1.255/27 ini kita panggil broadcast. Broadcast, all one subnet is broadcast. Right. And then defining host address for each subnet. Okay. So sekarang ni kita nak 25 host. Okay. So the all one host number broadcast address and subnet is 2 power 5. Mana datang 5 ni? 5 ni tadi kan kita dah design. Ni 1, 2, 3, 4, 5. Ni 3 ni subnet. Kita dah pakai. So ada balance kat sini kan. Daripada 8 ni, 8 tolak 3 jadi 5. Kat sini. Right. So this 5 lah because this one subnet. So kita start. Host 1, 0, 1, 2, 3, 4, 5, bla 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 sampai 30. Kenapa 30? Sebab kita ada 5 kan. 2 kuasa 5, 2 power 5 is 32. Tapi kena ingat, broadcast address and network subnet address kita tak boleh pakai, itu untuk sistem. So kita minus 2. So you got 30 hosts. So in each subnet, for example kita ambil contoh kita nak design subnet 2 lah, maksudnya branch nombor 2. Okay. So setiap branch tu kita bagi 30 host. So kita ada reserve 5 untuk future, 25 untuk dipakai sekarang. Okay. So and then ditukar macam ni. Kalau satu convert dia akan jadi .65 because 010 00001 convert to decimal you got 65. 010 000 65 67 68 bla 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 sampai 94. Okay, 95 tak boleh pakai sebab reserve for is it for broadcast. Okay. 0 kita tak boleh pakai .64 untuk default route. Okay. Baik. Ini contoh nombor 6. Okay, bahasa nombor 6 sama juga proses dia macam ni. Ikut je. Okay. 110 bila dari sini 0 ni dari sini. Subnet menang. Itulah. Sama proses dia, you repeat the same process. Okay, you repeat the same process from this dotted line, the binary, you convert to decimal, you dapat je lah 193, 194, 195, 96 and so on. So must be 30 host lah. Okay, 30 host. So yang ini dia punya all 0 and all 1. So dot 95 untuk for network address. This one for dot 223 for broadcast. Okay. Yeah. Alright. So this is another example lah. Okay, so tapi tak apalah, kalau banyak sangat awak baca kan you pening pula kan. So kita stop kat sini lah. Okay. Okay, don't worry about the note, lecture note I will given to you. Okay, don't worry, ini senang je. So next week kita jumpa. Okay, I will explain for the rest because this one mathematics, right? So you cannot do it everything in one go, so nanti you pening. Okay. Alright, thank you very much, guys. Good night. Okay. Assalamualaikum.
Thank you, Doctor.
Okay, Doctor.
Thank you, Doctor.
Thank you, Doctor.